it's your main math teacher, Mr. Boyd, and I'm back at it again, and today we're dealing with the chain rule, and we're getting sort of the end of our derivatives, and it's the chain rule, and the best way to understand that, before we get into any math, or my favorite way, is if we think about some Russian nesting dolls. And if you've never seen these before, what they are is they are little dolls, and they fit inside of each other. So when you buy them, usually all you see is this big doll, and this doll goes inside of that one, and this doll goes inside of that one, and so on, and they all fit inside of each other. And so thinking about that, if you wanted to get to that little tiny doll, the one that's on the very inside, and you had bought this big doll with all the others inside of it, what would you have to do to get to that little one so that you could play with it? Well, you'd have to take off, and if you can't tell, there's a little seam across here. You can actually take the top off, they come apart. So you'd have to take that one apart, and then you'd have to take the next one apart, and take the next one apart, until eventually you're down to the smallest one. And that's a really good way to think about the chain rule. We're starting with the outside of the function, and we just work our way in until we're done. So if today gets confusing at all, keep the Russian nesting dolls in mind as we start to take them apart. Now, why do we need a chain rule? Because we want to know how to take derivatives, or how to differentiate functions like these, where we have composite functions. So in this one, yeah, we've got that seventh power on the outside, but we also have a quadratic on the inside. And up until now, if we wanted to deal with that, we would have to write this out 7 times, multiply it all together, and then when we're old and gray, finally, we can get a result. Not today. It's going to be quick and easy. Okay? Or stuff like this. Maybe we have a root, it's a 4th root, that's kind of scary, and then we have a tangent inside of there. So that's what I'm talking about, functions inside of functions. We have a quadratic function inside of a 7th power. We have a 1 plus tangent on the inside of a 4th root, so we have little dolls inside of other dolls. That's why it's a good proxy for this concept. And so how does the chain rule go? It basically just goes like this. Like the Russian nesting dolls, we start on the outside, we work our way in. And so what that means, if you have a composite function, like g of h, outside function, inside function, what are you going to deal with first, the outside or the inside? Think nesting dolls. You have to start with the biggest function, the outside function. And so what that looks like is we take the derivative of g, and we leave the guts the same. Now, if you've been watching this video series, leaving the guts the same is something we've done a lot. So we've actually been doing the chain rule a lot. It's just we're formalizing it now today, finally. Okay? Once you've done that, you still have to take the derivative of every single function in your equation, and so the h equations, or the h function, still has to be derivatized, and so here it is. There's h prime on the outside. Okay? Let's look at some examples and get a little better at it. One example that we did in our previous lesson, we dealt with sine and cosine. And so yeah, we learned that sine turned into cosine, and I told you to just take my word for that. I said, come on, just write this down, you want this in your notes. But here's why. Because we have an outer function, and we have an inner function. Sine is on the outside, we start with that first. Sine turns to cosine. What about our inner function? We have that, and we need to also take a derivative of the inside function. And so there we are, we're taking the derivative of that, and it gets multiplied. That's all it is. Now I've got these arrows lining up with the actual rule, and so the g prime is the cosine, it's derivative of the outside. We leave the guts the same, there it is. We multiply by the derivative of the inside function, and there it is. Okay, so that's how the actual chain rule lines up with the sine rule. Now let's apply it to some new types of functions that would have been beyond our skills until today. And so let's do this one from the intro. Alright, with this one, all I'm going to do is I'm going to look for the outside function, that's the 7, and I deal with that first. So, think of this like it's something to the 7th power, like something to the 7th, x to the 7th. How would you have dealt with that? You would have said 7x to the 6th. Power rule, slide and subtract. Okay, we're going to do the same thing here. So I'm going to pull the 7 down, I'm going to subtract 1 from the exponent, and I get 7, and I get a 6 as an exponent. And remember, you're only dealing with one doll at a time. We dealt with the outside function. That means the guts are going to remain the same for now. So 3x squared plus 5x plus 9. Once we've done one step in the chain rule, we pause and we ask, have I taken a derivative of everything in this function? No. We dealt with the 7. We have not taken a derivative of this yet. So we're going to do that now. That is the inner function. So derivative of the inner function, 6x plus 5. They're multiplied together. That's all the chain rule is saying to do. Start with the outside function, do that first. Leave the guts the same. Then take the derivative of the guts, and they get multiplied together. Okay. Let's look at these. This one's very, very similar. If you don't know it yet, I want you to know differentiate is a command. It means find the derivative. Okay, so let's do this one. The outer function, that's the 100. Bring the 100 down. So minus 1, so I get 100 x cubed minus, oops, sorry about that, x cubed minus 3. Quantity to the 99th, multiplied by the derivative of the inside. A lot of people forget this when they're learning. You got to derivatize that right there. That's 3x squared. Now, if you want to simplify this out, if you want to multiply the 3 and the 100 together and get 300x squared x cubed minus 3, that would be fine. Probably a good idea to do that. So there's our derivative. Okay? And if we were really sharp, we'd say y prime equals. Okay? Now that lines up with this. In this one, they asked us for z prime, so they're asking for a derivative. The trick on this one, and actually we did this same trick when we learned the product rule, when we learned the power rule, is we're going to change out that square root for something different. We're going to rewrite it. Oops. We're going to rewrite it as 1 plus tangent of x to the 1/4 power. And so it's still easy to see. We have an outside function, we have an inside function. So here we go. We'll bring the 1/4 down in front. The 1 plus tan, the guts, remain the same. Subtract 1 from that, negative 3/4, and we multiply by the derivative of the inside function. 1 goes away, tan we learned last time turns into secant squared. Okay, and there's your finished derivative. That is z prime of x. Okay? But it wouldn't be a very good chain if it only had 2 links. That's not much of a chain at all. This rule applies to as many different functions, all composed together as you like. So in this one we've got 1. Sine of cosine of tangent of, okay, maybe 4. Sine of cosine of tangent of x. 1, 2, 3, 4. Okay, so let's go through this. The same rules apply. We start on the outside and we just work our way in until we get to the middle. So let's start on the outside. That would be sine. I'm going to write down my derivative of sine. I know that's cosine. What happens to the guts? They remain the same. So we've got a cosine, a tan, and an x. Cosine of tangent of x. Now match your parentheses up. So I got to close that one, got to close that one, got to close that one. We've dealt with the sine function. One thing that helped me when I was learning this, I say, okay, I've already taken a derivative of sine, that's gone. Now I'm looking at what's left that I have not yet taken a derivative of. I have not taken a derivative of cosine. That turns into negative sine. So I have negative sine of tan of x. Okay? Be really, really careful here. A lot of people will leave this like it is. Remember, the chain rule, we're multiplying all those different pieces together, not subtracting. And that right there says subtraction, so you need a set of parentheses around that. So be careful. Okay, I'm out of room on the left side. We're multiplying. The order doesn't matter. So I'm going to move to the front, and I'm not done yet. I'm going to write my next product on the front. So I've dealt with the cosine, turned into negative sine. Sweet. I have not taken a derivative of a tangent yet. We recall that that is secant squared of x. And the x remains the same. There it is. And then we also need to take a derivative of x. Derivative of x, that's 1. Since it's multiplied, I don't even have to write it. So that's done. That's a derivative. It's big, it's scary, but it is done. Okay? And we're going to end today with 2 fairly challenging ones. Suggest you pause the video here and give them a shot. Okay, and I'm going to run through them real quick. Okay, what we want to look at, it's the same rules as before. We want to recognize what's the outside function, what's the inside function, or inside functions in some of these cases. So with our first one, outside function, that's something raised to the 6th power. Do we know how to deal with things raised to the 6th power? Heck yeah, we do. So let's do it. Okay, so the 6 is going to come down, and I get the same old guts, x squared over x plus 1 to the 5th. Wonderful. People sometimes get here and they say, yay, I'm so good, I did a derivative, good for me. Hey, it's not done. You never took a derivative of the inside. So we need the derivative of that inside function. And that inside function is a quotient, which means it's time for the quotient rule. So I'm going to come down here and I'm going to start filling in my quotient rule stuff. F is x squared, and that means f prime is 2x. Hey, those are pretty friendly. X, sorry about that. And g is x plus 1, which means g prime equals 1. So lucky for us, fairly friendly cloud. Okay, let's fill that in. Okay, so we had our first chunk. Now we need the derivative of the guts. I'm going to fill it in right here where it belongs. multiplied f prime g, so that'd be 2x times x plus 1 minus g prime f, that's x squared, over g squared, x plus 1 quantity squared. Let's do some basic simplification here. Okay, so this, there's nothing I can do with that. I'm just going to rewrite it. So 6x squared, x plus 1. But over here, there are some things we can do. So when we multiply 2x and x together, that's 2x squared. 2x squared minus x squared is just x squared. We have two of them there, subtract one of them. 2x times 1, that gives me 2x. And I'm going to leave the denominator as it is. And I'm going to call that my derivative, mostly simplified. Okay? So that's that one. The hardest part is recognizing the form. There was nothing in this process that was particularly challenging, but some people forget that once they've taken the derivative of their outside function, they have to recognize that's a quotient. That's the hardest part. Let's take a look at the next one. I'm going to clear the ink on this one, so this is going away. Bye-bye. Rewind if you need to. Okay, let's look at the second one. Okay, on this one, again, we have to recognize what the outside or the big function is. And so we've got some inside functions. They're inside the parentheses. That's easy to see. I've got things to exponents, and I've got things multiplied together. And so what we have to decide, is this a product or is this a chain? And when we think about it, we almost have to ask, how would we do this? I mean, yeah, you say, oh, I'm pulling the 3, I'm pulling the 4, that's nice. But how are you going to deal with that multiplication? Ultimately, you are going to have to use a product rule. And if you're wondering if that's going to work or not, what I suggest is you just try it and see if anything goes weird. And here's what I mean by that. When you try to write down your f function and your g function, are you able to do it? So let's try it. Looks like I have something multiplied by something, that's probably f and g, and that captures every symbol in this function. So that indicates to me that the product rule is the right way to approach this. So let's write this down. X to the 4th minus 7x quantity cubed. And let's get this one, negative 3x cubed plus x squared to the 4th. Let's get the rest of our cloud figured out here. So f prime, and make sure you leave yourself some space. We're about to fill up the page a little bit here. Okay, so derivative time. Now this requires a chain rule. We have an outside function and an inside function. So 3 times x to the 4th minus 7x squared times the derivative of the inside, 4x cubed minus 7. And then let's continue. Let's find g prime. So for that, we bring the 4 down. 4 times negative 3x cubed plus x squared. That drops down to a third. And now we need the derivative of the inside. And so bring the 3 down. Negative 9x squared plus 2x. Okay, and that's our happy little cloud. Wonderful. And now that we've got that, all we have to do is fill in our product rule. And it's going to be a lot of symbols, but all the work, all the hard stuff, all of the thinking is done. That's what's nice about the product rule. Once you fill it in, you're just following a formula after that. It's a total piece of cake. So let's do it. And I'm thinking I'm probably going to run out of space. If you do run out of space, remember, what do mathematicians do when they run out of space? Same thing that poets do. They go to the next line. Okay, let's do this. F prime g. So here I go. 3 times x to the 4th minus 7x quantity squared times the quantity 4x cubed minus 7 times g. Remember, f prime times g. So times the quantity negative 3x cubed plus x squared quantity to the 4th. And then it's a plus g prime f. So here we go. 4 times negative 3x cubed plus x squared. Don't forget your parentheses. Negative 9x squared plus 2x. Remember, it's g prime times f, so we also need to include the f function. So that's x to the 4th minus 7x quantity cubed. Okay, question I get a lot right here is, well, wait, do we need to distribute? Do we need to simplify? And the question is, how would you? I mean, certainly you could. We could start multiplying all this junk together. let's save the rainforest and not, because remember, I really want to see that you have your calculus down. I'm assuming you can probably multiply numbers together. You don't need to prove that to me by multiplying all these out right now. So that's all it is. So what was tricky about this? Recognizing we got to do a product before we do the chain rule. The chain rule takes place within the cloud. Okay, so that's a handful of examples. Should be enough to get you going. That's going to be all for now. So until next time, we'll see you then, and have fun.